Hello students, welcome to this lecture on three-dimensional geometry. In this lecture, we will discuss NCERT exercise 11.2, question number 1 to 8. This is a disclaimer. So we will solve NCERT exercise 11.2, question number 1 to 8. I hope you are with your notebooks and pens ready. So now let's get started. In this question, we are given the direction cosines of three different lines. They are mutually perpendicular. Okay, so the three lines with the direction cosines are mutually perpendicular, and the direction cosines of three different lines are 12 divided by 13, comma, minus 3 divided by 13, comma, minus 4 divided by 13. So this is the direction cosines of for first line. For second line, direction cosines 4 by 13, comma 12 by 13, comma 3 by 13. For third line, direction cosine 3 by 13, comma minus 4 by 13, comma 12 by 13. So we are asked to show that three lines are mutually perpendicular to each other. So first of all, try it yourself and then see solution. Let's start the solution. Two lines with the direction cosines L1, M1 and N1 and L2, M2 and N2 are perpendicular to each other if L1 times L2 plus M1 times M2 plus N1 times N2 equals 0. So let's examine the first pair of lines given in the question. The direction cosines for the first line are 12 over 13. So here we call L1 equals 12 over 13. M1 equals minus 3 over 13. N1 equals minus 4 divided by 13. And the direction cosines for the second line are L2 equals 4 over 13. M2 equals to 12 over 13. And N2 equals 3 over 13. So we obtain now. So let's substitute these values into our perpendicularity condition. So we multiply the first components together, then the second components, and finally the third components, and add them all up. So we have here L1 times L2 plus M1 times M2 plus N1 times N2 equals 12 over 13 times 4 over 13 plus minus 3 over 13 times 12 over 13 plus minus 4 over 13 times 3 over 13. Now calculating each term, so we get 48 over 169 minus 36 over 169 and minus 42 over and minus 12 over 169. So when we add these together, the total is 0. Therefore, we can conclude that these two lines are perpendicular to each other. So let's continue with the solution. So now we will need to check the other pairs of lines as well to fully prove that all three lines are mutually perpendicular. For the lines with direction cosines, L1 equals 4 over 13, M1 equals 12 over 13 and N1 equals 3 over 13, and the direction cosines for the third line, that is L2 equals 3 over 13, M2 equals minus 4 over 13 and N2 equals 12 over 13. So now let's substitute these value into the perpendicularity condition. So here, look at here, L1 times L2 plus M1 plus M1 times M2 plus N1 times N2 equals 4 over 13 times 3 over 13 plus 12 over 13 times minus 4 over 13 plus 3 over 13 times 12 over 13. After calculating, we again find that the sum is 0. So this confirms that this pair of lines also is perpendicular. Therefore, we can conclude that the lines are perpendicular. So let's write out the solution. So here for the lines with direction cosines, L1 equals 3 over 13, M1 equals minus 4 over 13, N1 equals 12 over 13 and L2 equals 12 over 13, M2 equals minus 3 over 13 and N2 equals minus 4 over 13. We obtain by substituting these values into the perpendicularity condition, L1 times L2 plus M1 times M2 plus N1 times N2 equals 3 over 13 times 12 over 13 plus minus 4 over 13 times minus 3 over 13 plus 12 over 13 times minus 4 over 13. So now let's calculate. When we add these up, so 36 plus 12 minus 48 divided by 169 is 0. So the third and the first lines are also perpendicular. Therefore, since each pair of lines is perpendicular to each other, so we can now conclude that three lines are mutually perpendicular. Now, let's look at question number 2. In this question, we are given that two lines in 3D space. The first line passes through the points 1, minus 1, 2 and 3, 4, minus 2. This line is perpendicular to the line through the points 0, 3, 2 and 3, 5, 6. Okay, so first of all, try it yourself and then see solution. Let's start the solution. So let AB be the line joining the points 1, minus 1, 2 and 3, 4, minus 2 and CD be the line joining the points 0, 3, 2 and 3, 5, 6. Here is a diagram to help us visualize the problem. The points A and B define the first line and the points C and D define the second line in this diagram. If a line passes through 2 points, say X A, Y A, Z A and X B, Y B, Z B, then we know the direction ratios of a line passing through these points are XB minus XA, YB minus YB, ZB minus ZA. Now, let's calculate the direction ratios for the line AB. So, we subtract the coordinates of point A from point B. So, we will get the direction ratios A1, B1, C1 of line AB are 3 minus 1, 4 minus of minus 1 and minus 2, minus 2. That is 2, 5 and minus 4. Next, let's find the direction ratios for the line CD. So we do the same thing. So the direction ratios of line CD A2, B2, C2 are 3 minus 0, 5 minus 3 and 6 minus 2. That is 3, 2 and 4. Now, to check if the two lines are perpendicular, we use the condition for perpendicularity in 3 dimensions. If the sum A1 times A2 plus B1 times B2 plus C1 times C2 equals 0, then the lines are perpendicular. So let's calculate each part here. So A1 times A2 plus B1 times B2 plus C1 times C2 equals 2 times 3 plus 5 times 2 plus minus 4 times 4. Adding these up, 6 plus 10 minus 16 equals 0. Since the dot product is 0, this shows us that the direction vectors are perpendicular. Therefore, the two lines are perpendicular to each other. Now, let's look at question number 3. In this question, we are given two lines in 3D space. The first line passes through the points 4, 7, 8 and 2, 3, 4. And the second line passes through the points -1, -2, 1 and 1, 2, 5. And then we are asking here to show whether these two lines are parallel to each other or not. Okay, so first of all, try it yourself and then see solution. So let's start the solution. Let AB be the line through the points 4, 7, 8 and 2, 3, 4, and CD be the line through the points -1, -2, 1 and 1, 2, 5. So here in this diagram, the line passing through the point A and B, this is okay. So this is line 1, which is passing through the points A 4, 7, 8 and B 2, 3, 4. And line 2 is the line passing through the points C -1, -2, 1 and D 1, 2, 5. Now let's recall how to find the direction ratios of a line. If a line passes through 2 points, say XA, YA, ZA and XB, YB, ZB, then the direction ratios of that line are XB minus XA, YB minus YB, ZB minus ZA. Now let's calculate the direction ratios for the first line, which passes through 4, 7, 8 to 2, 3, 4. So the direction ratios A1, B1, C1 of line AB are 2 minus 4, 3 minus 7 and 4 minus 8. That is -2, -4 and -4. Next, let's find the direction ratios for the second line, which goes from -1, -2, 1 to 1, 2, 5. So here the direction ratios A2, B2, C2 of CD line are 1 minus of -1, 2 minus of -2 and 5 minus 1. That is 2, 4 and 4. So this gives us 2, 4 and 4 as the direction ratios for the second line. Now let's recall the condition for two lines to be parallel. Two lines are parallel if the ratios of the direction ratios are equal. In other words, A1 divided by A2 equals B1 divided by B2 equals C1 divided by C2. Now checking the condition for lines to be parallel. So we need to see if the ratios of the X, Y and Z components are all equal, then the lines are said to be parallel. So the ratio of the x components is a1 divided by a2 equals minus 2 divided by 2, which is minus 1. The ratio of the y components is minus 4 divided by 4, which also equals minus 1. The ratio of the z components is minus 4 over 4, which is also equals minus 1. Since all three ratios are equal, so we can say that direction vectors are proportional. That means the lines are parallel. So AB line is parallel to the CD lines, implies both the lines are parallel to each other. Now let's look at question number 4. In this question, we are given a point 1, 2, 3 through which a line passes, and we are told that the line is parallel to the vector 3 iota 3 I cap plus 2 j cap minus 2 k cap. So find the equation of the line. So first of all, try it yourself and then see solution. So let's start the solution. So here in this question, we have given the line passes through the point a1, 2, 3. Therefore, the position vector through point A is a vector equals a vector equals I cap plus 2j cap plus 3k cap. So now let's examine the information given here. So the line passes through the point A, which has coordinates 1, 2, 3. The position vector for this point is written as I cap plus 2j cap plus 3k cap, and the direction vector is any vector parallel to the given line. So vector B equals 3 I cap plus 2j cap minus 2k cap. Now notice that the direction vector of the line is given as 3 I cap plus 2j cap minus 2k cap. So this vector shows us the direction in which the lines moves. So any vector parallel to the line will have the same direction as this one. Okay, so here look at this diagram very carefully, okay, and try to visualize what we have given and what we have to do. So now we know that it is known that the line which passes through the point A and the parallel to B vector is given by vector R equals vector A plus lambda times vector B, where lambda is a constant. Now let's substitute the values we have into the equation. So R vector equals I cap plus 2j cap plus 3k cap plus lambda times 3 I cap plus 2j cap minus 2k cap. So this is the final answer. So the equation R vector equals I cap plus 2j cap plus 3k cap plus lambda times 3 I cap plus 2j cap minus 2k cap is the equation of the line passing through the given point A1, 2, 3 and is parallel to the vector 3 I cap plus 2j cap minus 2k cap. Now let's look at question number 5. In this question, we are given a point in space with the position vector 3 I cap minus j cap plus 4k cap and a direction for the given line by the vector I cap plus 2j cap minus k. And here we are asking to write the equation of the line that passes through this point and goes in this direction, both in vector form and in condition form. So first of all, think about this question. How would you approach this question? And then the solution. Let's start the solution. So first of all, visualize this diagram. Okay, so in this diagram you can see the line passes through the point with position vector 2 I cap minus j cap plus 4k cap. So the coordinates of the point which is on the line, that is 2, minus 1, 4. And this line is in the direction I cap plus 2j cap minus k cap. Okay. And then we have to find the equation of the line in vector and in condition form. So given information, point A on the line. So the coordinates of point A are 2, minus 1, 4. The position vector of the line of this point is vector A, that is 2i cap minus 1j cap plus 4k cap. Next, we have given vector B parallel to the line, and the vector B equals I cap plus 2j cap minus k cap. Any vector parallel to the line gives its direction vector of the line. So vector B equals I cap plus 2j cap minus k cap. Now substituting these values, and the equation becomes vector R equals A vector plus lambda times B vector. Okay. So vector R equals A vector plus lambda times vector B, where vector R equals xi cap plus yj cap plus zk cap. And vector R is the position vector of any arbitrary point on the line. And lambda is a scalar parameter, any real number. Now substituting A equals 2i cap minus j cap plus 4k cap and B equals I cap plus 2j cap minus k cap into the formula, vector R equals vector A plus lambda times vector B. Then we obtain vector R equals 2i cap minus j cap plus 4k cap plus lambda times I cap plus 2j cap minus k cap. So this is the vector equation of the line. Here is a visual representation of the line in 3-dimensional space. Notice how the line passes through the given point and follows the specified direction. And the general condition equation of a line passing through a point x1, y1, z1 with direction ratios a, b, c is given by x minus x1 divided by a equals y minus y1 divided by b equals z minus z1 divided by c. From the given point, which is 2, minus 1, 4. So we have identified the coordinates that the line passes through. So this is our starting point for the line. Here x1 equals 2. This is the x coordinate of the point on the line. Next, y1 equals negative 1. This is the y coordinate of the point. And z1 equals 4. This is the z coordinate of the point. Now, let's look at the direction vector, which is I cap plus 2j cap minus k cap. This vector gives us the direction ratios for the line. The first direction ratio A1 is 1. This is the coefficient of I cap in the direction vector. The second direction ratio B is 2. This comes from the coefficient of J. The third direction ratio C is negative 1. This comes from the coefficient of K. Now substitute x1 equals 2. Next, substitute y1 equals minus 1 and z1 equals 4 and a equals 1. And substitute b equals 2. And then substitute c equals minus 1 into the condition form. X minus x1 divided by a equals y minus y1 divided by b equals z minus z1 divided by c. And then we obtain x minus 2 divided by 1 equals y plus 1 divided by 2 equals z minus 4 divided by minus 1. So I think you are getting my point. So this is the condition equation of the line. I hope you are getting my point. and this question is clear to all of you. So now let's move to the next question. In this question, you are given a point -2, 4, -5 and a line whose equation is x plus 3 by 3 equals y minus 4 divided by 5 equals z plus 8 divided by 6. Okay, and we need to find the Cartesian equation of a new line that passes through the given point and is parallel to the given line. So let's start the solution. The given information, line passes through the point x1, y1, z1 equals -2, 4, -5. And now notice that our line is parallel to the another line, which is given in symmetric or Cartesian form, that is x plus 3 over 3 equals y minus 4 over 5 equals z plus 8 over 6. Here is a visual representation to help us understand the problem. Okay, so the diagram shows the given point and the direction of the parallel line. So this will help us visualize how the two lines relate to each other in space. Now let's recall an important property. So we know if two lines are parallel, then their direction ratios are proportional. In the Cartesian equation of a line, x minus x naught over a equals y minus y naught over b equals z minus z naught over c. The denominators a, b and c represent the direction ratios of the line. Now let's substitute our values into this formula. Then the point is -2, 4, -5 and the direction ratios are 3, 5, 6. So the equation becomes x plus 3 over 3 equation becomes, which is parallel to the line, x plus 3 over 3 equals y minus 4 over 5 equals z plus 8 over 6. That is, here we obtain a equals 3, b equals 5 and c equals 6. Since our new line is parallel to this given line, it will have the same direction ratios. So for our new line, the direction ratios are a, b, c equals 3, 5, 6. Then the Cartesian equation of a line passing through a point x1, y1, z1 and having direction ratios a, b, c is given by the formula we just used. That is x minus x1 over a equals y minus y1 over b equals z minus z1 over c. And here is a visual representation of the line in three-dimensional space. Now substituting x1, y1, z1 equals -2, 4, -5 and a, b, c equals 3, 5, 6 into the formula, and we get the equation for our line. So we can write x minus of -2 over 3 equals y minus 4 over 5 equals z minus of -5 over 6. So this was our substitution before simplifying the numerators. So after simplifying, we have x plus 2 over 3 equals y minus 4 over 5 equals z plus 5 over 6. So this is the Cartesian equation of the required line. Now look at question number 7. In this question, we are given the Cartesian equation of a line, that is x minus 5 over 3 equals y plus 4 over 7 equals z minus 6 over 2. So here in this question, we are asked to write the equation in its vector form. So first of all, try it yourself and then the solution. So let's start the solution. So given Cartesian equation, x minus 5 divided by 3 equals y plus 4 divided by 7 equals z minus 6 divided by 2. Now notice how the general Cartesian form of a line in 3D is written as x minus x1 over a equals y minus y1 over b equals z minus z1 over c. By comparing our given equation to the general form, we can pick out the values for x1, y1 and z1. From this comparison, we see that x1 is 5, y1 is -4 and z1 is 6. So the position vector of this point is 5 cap minus 4 cap plus 6 cap. This vector points from the origin to the point 5, minus 4, 6 on the line. Now identify the direction ratios and from the direction vector. So the denominators in the Cartesian form represent the direction ratios a, b, c. So from the standard form, x minus 5 over 3 equals y plus 4 over 7 equals z minus 6 over 2. We obtain a equals 3, b equals 7 and c equals 2. So the direction vector parallel to the line is vector b equals 3 cap plus 7 cap plus 2 cap. Then the vector equation of a line passing through a point with position vector a and the parallel to a vector b is vector r equals vector a plus lambda times vector b, where vector r equals xi cap plus yj cap plus zk cap. Okay, and vector r is the position vector of any point on the line and lambda is a scalar parameter. Now substitute a equals 5 cap minus 4 cap plus 6 cap and b equals 3 cap plus 7 cap plus 2 cap into vector r equals vector a plus lambda times vector b. Then we obtain vector r equals 5 cap minus 4 cap plus 6 cap plus lambda times 3 cap plus 7 cap plus 2 cap. So this is the vector form of the given line. So I hope this question is clear to all of you. So now let's move to the next question. In this question, we are given two pairs of lines in vector form. For each pair, we need to find the angle between the two lines. So first of all, think about this. How would you approach this question and then the solution? So first of all, let theta be the angle between the given lines. And then the formula for the angle between two lines whose directions are given by vectors a1 vector and b2 vector is cos theta equals absolute value of b1 vector dot product b2 vector divided over absolute value of b1 vector times absolute value of b2 vector. From the given equations, vector r equals 2 cap minus 5 cap plus cap plus lambda times 3 cap plus 2 cap plus 6 cap and vector r equals 7 cap minus 6 cap plus mu times I cap plus 2 cap plus 2 cap. Here, first of all, visualize the diagram here. Okay, so here these are two line and they are intersecting at point this. Okay, and they make angle theta between these two lines. The direction vectors are vector b1 equals 3 cap plus 2 cap plus 6 cap and vector b2 equals I cap plus 2 cap plus 2 cap. Now we calculate the magnitudes of these vectors. So let's calculate magnitude of b1, that is square root of 3 square plus 2 square plus 6 square, which is equal to square root of 9 plus 4 plus 36 equals square root of 49 equals 7. And magnitude of B2 vector equals square root of 1 square plus 2 square plus 2 square, which is equal to square root of 1 plus 4 plus 4, which is equal to square root of 9 equals 3. Next, we calculate the dot product of the two vectors. So B1 vector dot product B2 vector equals 3 cap plus 2 cap plus 6 cap dot product I cap plus 2 cap plus 2 cap. So this is equal to 3 times 1 plus 2 times 2 plus 6 times 2. This is equal to 3 plus 4 plus 12 equals 19. Now substitute absolute value of B1 vector, which is 7, and magnitude of B2 vector, which is 3, and B1 dot product B2 equals 19 values into the formula cos theta equals absolute value of B1 vector dot B2 vector divided by magnitude of B1 vector dot multiplied with magnitude of B2 vector. So we obtain cos theta equals absolute value of 19 divided by 7 into 3. It implies cos theta equals 19 divided by 21. Finally, to find the angle theta, we apply cos inverse to the both sides. Then we obtain theta equals cos inverse of 19 divided by 21. Now let theta be the angle between the given lines, and the formula for the angle between two lines with directions are given by vectors b1 and b2 is cos theta equals to absolute value of b1 vector dot product b2 vector divided by magnitude of b1 vector times magnitude of b2 vector. From the given equations, vector r equals 3 cap plus j cap minus 2 cap plus lambda times I cap minus j cap plus minus 2 cap, and vector r equals 2 cap minus j cap minus 56 cap plus mu times 3 cap minus 5 cap minus 4 cap. Here is a diagram that visually represents the two lines and their direction vector in three-dimensional space. So the direction vectors are b1 equals I minus j minus 2 cap, and b2 vector equals 3 cap minus 5 cap minus 4 cap. Now we calculate the magnitudes of these vectors. Magnitude of b1 vector equals square root of 1 square plus minus 1 square plus minus 2 whole square equals square root of 1 plus 1 plus 4 equals square root of 6. And magnitude of b2 vector equals square root of 3 square plus minus 5 square plus minus 4 whole square equals square root of 9 plus 25 plus 16, which is equal to square root of 50, and square root of 50 can be written as square root of 25 times 2, which is equal 5 times root 2. Next, we calculate the dot product of the two vectors. b1 vector dot product b2 vectors equals I cap minus j cap minus 2 cap dot product 3 cap minus 5 cap minus 4 cap, which is equal to 1 into 3 plus minus 1 times minus 5 plus minus 2 times minus 4, which is equal to 3 plus 5 plus 8, and this is equal to 16. Now substitute magnitude of b1 vector equals square root of 6 and magnitude of b2 vector equals 5 times root 2, and b1 vector dot product b2 vector equals 16 values into the cos theta equals to absolute value of b1 vector dot product b2 vector divided by magnitude of b1 vector product with magnitude of b2 vector. Then we obtain cos theta equals absolute value of 16 divided by square root of 6 times 5 times root 2. So it implies cos theta equals 16 divided by 5 times square root of 12, since square root of a times square root of b equals square root of a times b. It implies cos theta equals 16 divided by 5 times square root of 4 times 3. So we see the formula cos theta equals 16 divided by 5 times 2 times square root of 3. Simplify the denominator, then we obtain cos theta equals to 16 divided by 10 times root 3. It implies cos theta equals 8 divided by 5 times root 3. Finally, to find the angle theta, we apply cos inverse to both sides. Then we obtain theta equals cos inverse of 8 divided by 5 times root 3. So this is our final answer. That's all for today's lecture. So thank you for your attention. I hope this lesson was helpful to all of you.